Imagine waking up tomorrow and deleting every app on your phone. No YouTube, no TikTok, no Instagram, no games. For the first few minutes, nothing feels different. Then, without even thinking, you reach into your pocket. Your phone isn't there. A few minutes later, you do it again. Then again. Not because you need to call someone, not because you have an important message waiting, but because your brain expected something. If you've ever experienced this, you've probably heard the same explanation everyone else has. You're addicted to dopamine. In fact, you've probably seen videos telling you to do a dopamine detox. They promise that if you stop using social media, stop playing games, stop eating junk food, or stop watching YouTube for a few days, your brain will somehow reset. It's a simple explanation, it's easy to understand, and that's exactly why it's become so popular. But here's the problem. It's not really how dopamine works. Dopamine isn't the chemical that makes you happy. It isn't the reason chocolate tastes good. It isn't released every time you experience pleasure. And despite what countless self-help videos claim, you can't flush dopamine out of your brain or permanently reset it with a weekend detox. The real story is far more interesting. Because dopamine isn't really about pleasure. It's about pursuit. It's about learning, about prediction, about motivation. And once you understand what dopamine is actually doing, you'll begin to see your everyday habits in a completely different way. Why checking your phone feels automatic. Why starting difficult work feels almost painful. Why motivation seems to disappear overnight. And why your brain keeps pulling you toward distractions, even when you know they're making your life harder. To understand all of this, we first need to answer a surprisingly simple question. What exactly is dopamine? Dopamine is a neurotransmitter. That simply means it's one of the chemicals your brain uses to allow billions of nerve cells to communicate with one another. Every thought you've ever had, every memory, every decision, every movement, depends on neurons constantly sending tiny electrical and chemical signals. Dopamine is one of the messengers carrying those signals. But unlike what many people believe, dopamine doesn't have just one job. It plays a role in movement, learning, decision-making, reinforcement, motivation, and many other brain functions. In fact, the importance of dopamine becomes obvious when it stops working properly. One of the clearest examples is Parkinson's disease. People with Parkinson's gradually lose dopamine-producing neurons in a region of the brain called the substantia nigra. As dopamine levels decline in those pathways, movements become slower and more difficult. Simple actions, standing up, walking, buttoning a shirt, can become challenging. This tells us something important. If dopamine were simply the pleasure chemical, losing it wouldn't make movement so difficult. Clearly, dopamine is doing much more than producing feelings of happiness. Scientists have known this for decades, yet somehow, the internet turned dopamine into a simple reward chemical. Why? The answer goes back to a series of experiments that fundamentally changed neuroscience. For many years, researchers believed that the brain worked in a fairly straightforward way. Do something good, receive pleasure. Do something painful, avoid it next time. Simple. Then researchers began studying how animals learned from rewards. One famous set of experiments involved monkeys performing simple tasks. A light would turn on. A short time later, the monkey would receive a drop of fruit juice. Researchers recorded the activity of dopamine-producing neurons during this process. At first, the results seemed exactly as expected. When the unexpected juice arrived, dopamine neurons fired strongly. It looked like dopamine really was responding to rewards. But something fascinating happened after the monkeys repeated the task enough times. The dopamine response began to change. Eventually, the neurons stopped responding strongly when the juice actually arrived. Instead, they fired the moment the light appeared. The reward hadn't changed. The juice was exactly the same. What changed was the monkey's expectation. The brain had learned that the light predicted the reward. In other words, dopamine wasn't celebrating the reward itself. It was responding to the prediction that something valuable was about to happen. That discovery completely changed how neuroscientists understood dopamine because it suggested that dopamine wasn't saying, "This feels good." Instead, it was saying, "Pay attention. Something important is about to happen." That tiny difference changes everything, because if dopamine is really about prediction and motivation, then suddenly, many modern behaviors begin to make sense. why notifications are so irresistible, why slot machines are addictive, why social media can keep us scrolling for hours, and why simply seeing your phone on the table can make concentrating on work feel so much harder. But there's another twist. Sometimes dopamine becomes even stronger. Not when you get the reward, but when the reward is uncertain, and that single discovery helps explain why some of the most addictive products in the world are designed the way they are. Imagine you're checking your email. Most of the time there's nothing interesting. Maybe a receipt, a newsletter you forgot to unsubscribe from, or another promotional email. But every once in a while, there's something exciting. A message from a friend, a job interview, good news you've been waiting for. Now ask yourself this. If you knew every single email would be boring, would you check your inbox nearly as often? Probably not. The excitement doesn't come from opening your inbox. It comes from not knowing what you'll find, and that's exactly what fascinated neuroscientists. After discovering that dopamine responded to predictions rather than rewards themselves, researchers uncovered something even more surprising. The brain doesn't simply ask, "Did I get a reward?" Instead, it constantly compares reality with expectation. Was the outcome better than expected? Worse? Or exactly what I predicted? This process is called reward prediction error, and it's considered one of the most influential ideas in modern neuroscience and reinforcement learning. In simple terms, your brain is always making predictions about the future. Every action you take comes with an expectation. Will this meal taste good? Will someone reply to my message? Will this investment pay off? Will opening this app be entertaining? When reality differs from your expectation, dopamine neurons respond. If something turns out better than expected, dopamine activity briefly increases. If it matches what you expected, there's very little change. And if the outcome is worse than expected, dopamine activity briefly decreases. Notice something important. The brain isn't just rewarding pleasure, it's measuring surprise. It's updating its internal model of the world. It's learning. And from an evolutionary perspective, this makes perfect sense. Imagine two early humans searching for food. The first always finds berries in the same place. The second suddenly discovers an entirely new area filled with fruit. Which discovery is more valuable? The unexpected one. Your brain is constantly searching for information that helps you survive and adapt. Unexpected rewards teach you something new. Expected rewards don't. That's why dopamine is so closely tied to learning, not happiness. This idea also explains one of the strangest features of human behavior. Sometimes, not knowing is more exciting than knowing. Think about buying a lottery ticket. Objectively, your chances of winning are incredibly small. Most people know they'll lose. Yet, the moment they buy the ticket, something changes. For the next few days, they imagine possibilities. What if I actually win? What would I do with all that money? That period of uncertainty can be emotionally powerful, even though the most likely outcome is disappointment. The same principle appears in gambling. If every pull of a slot machine paid exactly $5, people would quickly lose interest. There would be no mystery, no anticipation, no surprise. Instead, slot machines use what's known as a variable reward schedule. Sometimes you win. Sometimes you lose. Sometimes you almost win. That unpredictability keeps people engaged because the brain continues asking, maybe the next one will be different. Interestingly, this wasn't just discovered in casinos. Psychologists had observed decades earlier that behaviors reinforced on unpredictable schedules can become remarkably persistent. The psychologist B.F. Skinner showed that animals often continued pressing a lever longer when rewards arrived unpredictably than when every press was rewarded. It's important not to oversimplify these findings. Human behavior is much more complex than animal experiments, and gambling involves many psychological, social, and environmental factors. But the broader principle, that unpredictable rewards can strongly reinforce behavior, has been replicated across many contexts. Now think about your phone. Every time it vibrates, you don't know what happened. Maybe it's a meme. Maybe it's bad news. Maybe someone liked your photo. Maybe it's completely unimportant. That uncertainty matters. Social media platforms don't need every notification to be exciting. They only need some of them to be. Because your brain keeps learning that checking might reveal something valuable. The same is true when you refresh a feed. One swipe is boring. The next reveals an interesting story. Then several forgettable posts. Then a hilarious video. Then breaking news. Then something emotionally charged. The exact sequence is unpredictable. Each refresh carries possibility. This is why people often describe scrolling as something they never intended to do for an hour. They're not usually chasing one specific post. They're chasing the chance that the next post will be worth seeing. Modern digital platforms are designed around novelty. Our attention is naturally drawn to things that are new, surprising, or emotionally significant, because throughout human history, those signals often mattered for survival. Today's technology didn't create that tendency. It learned how to capture it. But here's where another common misunderstanding appears. If dopamine motivates us to pursue rewards, why don't we feel equally motivated to study, or exercise, or work on a long-term goal? After all, those activities also have rewards. The answer lies in timing. Your brain doesn't value every reward equally. It tends to discount rewards that are far away in time. Psychologists call this temporal discounting. Imagine someone offers you two choices. You can receive $50 today, or $60 1 month from now. Logically, waiting earns you more money, yet many people choose the immediate reward. Not because they're irrational, but because immediate outcomes often feel more valuable than delayed ones. From an evolutionary perspective, this bias made sense. Our ancestors couldn't assume future resources would always be available. A meal today could matter more than the possibility of a larger meal weeks later. That ancient tendency still influences modern decisions. Studying for an exam may improve your future. Going to the gym may improve your health months from now. Building a business may take years before it succeeds. Meanwhile, your phone offers novelty in seconds. Your favorite game offers immediate feedback. A streaming platform delivers entertainment instantly. One reward is delayed, the other is immediate. Your brain naturally notices the immediate one more strongly. That doesn't mean you're lazy. It means your brain is weighing rewards using rules that evolved in a very different world. And once you understand those rules, you can stop blaming yourself and start designing your environment to work with your brain instead of against it. By now, you might be wondering something. If dopamine isn't simply the pleasure chemical, and if our brains naturally respond to novelty and uncertainty, does that mean technology is changing our brains forever? It's a question that appears in headlines all the time. Social media is destroying your attention span. Your brain is fried. Your dopamine receptors are broken. These claims are dramatic. They're memorable. But the truth is more complicated. The human brain is incredibly adaptable. Neuroscientists refer to this ability as neuroplasticity, the brain's capacity to change in response to experience. That adaptability is one of our greatest strengths. It allows us to learn languages, develop skills, recover from injuries to some extent, and build new habits throughout life. So, yes, repeated behaviors can strengthen certain patterns of attention and decision-making. But that doesn't mean your brain is permanently damaged because you spent too much time on social media. What often changes first is behavior, and behavior shapes experience. Imagine two people. The first wakes up, checks notifications immediately, scrolls through short videos during breakfast, answers messages every few minutes, and spends the day switching between work and entertainment. The second also uses technology, but they've turned off most notifications. They work for an hour before checking their phone and intentionally separate focused work from leisure. Neither person has a completely different brain, but over weeks and months they're practicing different habits. One is constantly training rapid task switching. The other is repeatedly practicing sustained attention. Like any skill, attention improves with practice, or weakens when we rarely use it. This brings us to one of the most misunderstood trends online, the dopamine detox. The idea sounds appealing. Avoid all pleasurable activities for a day or a weekend. No social media, no video games, no junk food, no music, no entertainment. Then, supposedly, your dopamine levels reset and everything becomes enjoyable again. It's a compelling story. The problem is that it's not an accurate description of how dopamine works. Your brain doesn't stop producing dopamine because you watched YouTube. And it doesn't reboot like a smartphone after a weekend without Instagram. Dopamine is involved in countless essential functions every single day. It's active when you move, when you learn, when you anticipate, when you make decisions, and even when you're simply navigating your environment. You can't turn dopamine off. What many people experience after taking a break from constant digital stimulation isn't a dopamine reset. It's often something much simpler. They're reducing the number of distractions competing for their attention. Imagine walking into a room where 10 people are shouting your name. Then, imagine 9 of them leave. The remaining voice suddenly feels much easier to hear. Your brain didn't fundamentally change in a single afternoon. The environment did. When you remove constant interruptions, your mind has fewer competing signals to process. That can make slower activities, reading, studying, writing, even taking a walk, feel easier to engage with. The benefit comes from changing your environment and your habits, not from emptying your brain of dopamine. That's an important distinction because it changes how we solve the problem. If you believe your brain is broken, you'll look for a miracle cure. If you understand that your environment shapes your behavior, you'll start changing the environment instead. Psychologists have known for decades that our surroundings strongly influence our actions. We like to think we make decisions through pure willpower. In reality, our environment quietly nudges us in one direction or another. Consider a simple example. You're trying to read a book. Your phone is sitting face down beside you. It doesn't ring. It doesn't vibrate. You don't even pick it up. Yet, several studies suggest that merely having a smartphone nearby can draw on aspects of our attention, even when we're trying to ignore it. Researchers are still exploring exactly how and when this happens, but the broader idea is clear. Cues in our environment can compete for our limited mental resources. Your brain is constantly monitoring possibilities. Did someone message me? Am I missing something? Should I check just for a second? You may not consciously notice those thoughts, but they create friction. Now imagine the phone is in another room. Suddenly, checking it requires standing up, walking over, and making a deliberate decision. You've added friction. Behavioral scientists often find that even small increases in effort can reduce how often we perform a behavior. Likewise, making a desired behavior easier can increase the chances that we'll actually do it. This is why many productive people don't rely on extraordinary self-control. They design their environments. If they want to read, the book stays on the desk. If they want to exercise, the workout clothes are already laid out. If they want to write, distracting websites are blocked during work hours. They're not necessarily more disciplined. They're making the right choice easier and the wrong choice slightly harder. Another lesson from psychology is that motivation often follows action, not the other way around. Many of us wait until we feel motivated before starting. But research on habits and behavior change suggests that getting started is often the hardest part. Once you're already engaged in a task, continuing becomes easier. That's one reason techniques like breaking a project into tiny first steps can be effective. Instead of telling yourself to write a report, you tell yourself to open the document. Instead of study for 3 hours, you begin with 5 minutes. The goal isn't to trick your brain, it's to lower the barrier to getting started. Momentum builds gradually. Think of pushing a heavy car. The first movement requires the most effort. Once it's rolling, keeping it moving becomes much easier. Our behavior often works the same way. So where does all of this leave us? Dopamine isn't your enemy. It's not the villain secretly ruining your life. Without dopamine, you wouldn't explore. You wouldn't learn from experience. You wouldn't pursue goals. You wouldn't feel curiosity about the world. The problem isn't dopamine itself. The challenge is that we now live in an environment filled with systems competing for our attention every minute of the day. Companies invest enormous resources into making products more engaging because attention is valuable. That doesn't make technology evil. It simply means we should understand how these systems interact with the way our brains naturally learn and respond. Once you understand those mechanisms, you can make more intentional choices, not by fighting your brain, but by working with it. The next time you instinctively reach for your phone, pause for a moment. Ask yourself a simple question. What am I expecting to find? Because that's what dopamine has been doing all along. Not rewarding pleasure, not chasing happiness, but constantly asking, could something important happen next? Understanding that changes the conversation. The goal isn't to eliminate dopamine. The goal isn't to live without pleasure. The goal is to become aware of what your attention is being trained to pursue. Every notification you answer, every habit you repeat, every choice you make is teaching your brain what's worth paying attention to. And over time, those small lessons become the patterns that shape your life. So perhaps the real question isn't, how do I detox from dopamine? It's, what do I want my brain to keep learning tomorrow?